be on your final exam, function notation. We should know how to do it by now. If I say f of 2, what are you going to do? Huh? You're just going to plug it in on the right-hand side of the equation, right? So I'm going to do 2 cubed minus 2 plus 1 into the equation. And then this would be a good mental math question. What is 2 cubed? Remember order of operations? I would do 8 first. Then I would subtract 2. So 8 minus 2 is 6. And then 6 plus 1 would give me 7. See if you can plug in -1 now into that original function and see if you can plug in 0 into that original function. You should be able to do them using mental math, I think. So you're plugging in -1 and you're plugging in 0 and see what you get. We are cubing, this would be negative here, right? Because you're cubing a negative. But then this is minus a minus, so this one will become a plus. So you are cubing a -1, then you're subtracting a -1, and then you're adding 1. So the first -1 will stay -1, right? Because it's cubed. Then you'll add the second one. Then you'll add the third one. So it looks like you get +1 as the answer. When you cube a negative, it's still negative, right? Because it's a negative times a negative times a negative. A double negative here in the middle, because you're subtracting a negative number, becomes a positive. And then the last one, when I plug in 0, I would get 0 minus 0 plus 1. So that would just give me 1 for the last problem. So that shouldn't be something that's new, but I just wanted to refresh your memory. I think there's 1 or 2 like that on either the homework or the quiz as well. Okay, so now operations with polynomials. I threw this on there not to trick you, just so you know, you might see this written differently on the SAT or on my test or quiz. So just knowing that adding 2 functions together could be written like this, or you could put the plus sign in between the f and the g and write of x. This is not multiplication. You're not multiplying anything times x. It's just function notation. And what I see the most is I see students multiplying by some extra x that they're making up from somewhere. This is just adding 2 functions together, subtracting 2 functions, and multiplying 2 functions. So it's just telling you what to do. It's not actually telling you to multiply something by x. So if you have these 2 functions, all you're doing is adding the 2 functions together. And when you add them together, you can only add the like terms of x's. So let's add this together. Let's see. If I'm going to have to write it in standard form, I should look for the biggest power first. So I like to circle them as I go. So here's an x cubed. Here's another x cubed. How many x cubes do I have altogether? I have +2 and I have -4. So I have -2x cubed. You're like adding together the terms, you don't change the variable. All right, do I have any x squared terms? So it looks like I only have one x squared term. So I'm going to write plus 3x squared next. So I'm going to kind of cross off. I use that, I use that, I use that. So how many x terms do I have? Just this one here, right? So minus 3x. Then I have this 4 and this 17 that are going to get added together. So plus 21. I like addition better than subtraction because I don't have to worry about the minus sign. When I do subtraction, what I do first is I just distribute the entire negative sign first. So if it were me, I would rewrite my problem. I don't usually rewrite the stuff on the left, but I would write this as minus 4x squared minus 10x and minus 3x cubed. Just so when I'm circling my terms, I'm circling like, oh, this was a negative or this was a positive. You're distributing the negative sign over the parentheses. So if this had been a minus sign here, like you would have distributed a minus minus and it would become a plus. So you're just changing the sign to each of them. So now I can do my strategy with the biggest term. 5x to the 6th is the biggest, right? So I'm going to write 5x to the 6th first and cross that term off. What comes next? My x cubed, right? I have a negative 3x cubed here, and I have another negative 3x cubed here. So that's a total of negative 6x cubed. Negative 6x cubed. So I'm going to cross those two off. And then what do you notice happens next to your x squared terms? You have a positive 4 and you have a negative 4. So that adds up to 0. Cross those out. So then it looks like I just have minus 10x and minus 20. So addition and subtraction are not difficult, but you have to stay organized. So you have to make sure that you distribute if you see a negative sign and you go one step at a time and cross things off, because it gets like really big really fast. So you have to stay organized and cross them off as you go. So addition and subtraction, you can try some practice in a couple minutes. Actually, this is practice for addition and subtraction right here. So now they're giving you two functions up top, f of x and g of x. They want you to add them together. So example 3 says f plus g. So I'm adding f plus g. Example 4 says take g and add f. Are those going to come out the same? If I add f plus g or g plus f, those will come out the same. What about if I subtract though? So if I take f and I subtract g, these terms are all going to get the negative sign, right? But if I go in the other direction, if I start with g and I subtract f, will that come out the same? So down here it says which operation is commutative? Commutative means the same forwards as backwards. Commutative means the same forwards and backwards. So which operation is the only one that's commutative? Addition. So if I'm doing addition, it doesn't matter the order, but if I'm doing subtraction, I'm actually going to have to do it and see what I get. Why don't you try to do example 3 now and see what you get? Take your f, add your g, and write your answer in standard form. And then we know that that answer is just going to be the same for example 4. So try it for 1 minute on your own. Take f and add g. And write your answer in standard form. So you have 2x squared plus 1x squared, so you should have 3x squared terms. You only have one x term, so plus x. And then you have a positive 4 plus a negative 9 would be negative 5. So that's the same over here, 3x squared plus x minus 5. All right, I'm going to set up example 5 so that you don't make any mistakes. So I'm going to copy down that f of x would be 2x squared plus x plus 4. But now it says minus g of x. So I'm going to distribute a negative sign up here. So that would give me negative x squared, but a positive 9. So now you're going to add those terms together because I already distributed the negative sign. So you should be able to add together your like terms and find the answer to example 5. So you have a 2x squared minus an x squared. So that should just give you 1x squared left. So you could either write 1x squared or just x squared. Then you just have plus x, and then you'd have what? Plus 13, because you have a 9 and a 4. All right, so now let's set up example 6 and see how it comes out different. So g of x this time is x squared minus 9, so that comes first. I need to subtract the entire f of x function. So I'm going to write that as minus 2x squared minus x and minus 4. Now you can add together your like terms without making any mistakes. So try to always write out the work if you have to distribute a negative sign. See if you can write that final answer. I think this was from when you worked here yesterday. Okay. Okay. I also. All right. So let's see. X squared minus 2x squared is a negative x squared, then a minus x, and then a minus 13. I just want you to compare what's the difference in my two answers. They are exactly opposite. So when you flip with the subtraction sign, if this had been positive, then this one would be negative. If this one had been negative here, then this one would be positive here. So all the signs come out opposite because you switched the order. So does that seem like you understand addition and subtraction? So the last one we're going to look at today is multiplication. And some of you, I think, did the FOIL method, and some of you did the box method when we were multiplying in quadratics. So I'm going to show you both, and you can do it either way you want. So I think most of us did the box method. So I think I'm not going to write the FOIL method on my sheet. I'll do the FOIL method over here in just a second if that's more familiar. So I'm going to do the box method first. I think that's the one that you guys learned with quadratics or practiced. So the box method, this is really 2x minus 3 times 2x minus 3. So you put your binomials on the outside of a box and you multiply them together inside the box. It's kind of like factoring in reverse. You know the binomials and you're trying to come up with the standard form quadratic. So you would do 2x times 2x is 4x squared because we're multiplying now, right? And then 2x times negative 3 would be negative 6x. And then this 2x times this negative 3 is also negative 6x. And then negative 3 times negative 3 would give me a positive 9 in this box. Then, now that you have these four terms all multiplied inside the box, you need to write it in standard form. So you're going to add together any like terms. So I would have 4x squared. I have a negative 6x and a negative 6x. So I have a negative 12x, and then I have positive 9. So if you were going to do the same method with FOIL, it just means you're doing it in your head instead of writing out in the box. Once you get to like big pre-calculus, writing it out of the box is like a little bit time consuming. You should be able to kind of go in your head and say, that would give me 4x squared. That's called the first. Then you do, it's called outer and inner. So my outer is these two, 2x times negative 3, and my inner is also 2x times negative 3. So negative 6x, negative 6x. And then this is called your last. So negative 3 times negative 3 is the last in each of the two terms. See how it gives you the same answer. 4x squared minus 12x plus 9. This is how I always learned it. First, outer, inner, last, FOIL. You always FOIL binomials. For some reason at Kennett, they always do the box and whatever. I just think that students get too reliant on the box. And at some point, mental math skills make your job faster in math. But for Algebra 2, if you're comfortable with the box method, then that's good. I like the box method for example 2 because now you've got a binomial times a trinomial. So the box actually helps you keep your work more organized, I think, because now you don't have two binomials. So you're going to draw a box so that you can put your binomial on one side of the box and your trinomial on the other side of the box. So you're going to have to do 6 multiplication problems and then you're going to have to add together your like terms. So now that I set the box up for you, I want you to try multiplying them together and see what you would get inside your box. And I'll put mine up in a minute. If you want to wait to write standard form to make sure that you have the right answers inside the box, you could wait. I'll put mine up so that as you're finishing, you can just check to see if you've got the right terms. And it's okay in your head to like say the multiplication step out loud, x times x squared, x times 3x, or else you start to add by mistake. So I always do like the times in my head, x times 1 is x. And then I go, okay, now 2 times all these things, I'm just doubling, right? 2x squared, 2 times 3x is 6x, 2 times 1 is 2. That's the multiplication step. Now you're going to add your like terms to put it in standard form. So I would have just x cubed. If you notice, sometimes your like terms show up on the diagonal. So I would have plus 5x squared. Thank you. And then I have 6x plus 1x. So I have plus 7x and then plus 2. So that would be your final answer for that one. Okay, so example 3 is slightly different. I'm going to get you set up on example 3, and then you're going to do kind of the same method that we just did. You are not allowed to distribute that cube and say that this is x cubed plus 64. So you need to first write out that you have x plus 4 times x plus 4 times x plus 4, as painful as that is. So then 2 of them you are going to multiply together, either using the box method or the FOIL method, and figure out what this trinomial would be first. See, then you're going to get a trinomial here times another binomial here. So it's a lot of multiplication. So if you want to set up the box for these two terms, you're going to do x plus 4 times x plus 4 and figure out what you get as your new trinomial. Some of you might think that this is fun. It's just computation, operations. I feel like there's less critical thinking. It's just multiplying, just a skill. I kind of like it. It's less thinking than factoring, right? You're just multiplying. So in some ways, you might think that this is relatively easy compared to some of the stuff we've learned this year, but you've got to stay organized. So x times x is x squared. I would get 4x here, and 4 times 4 is 16. So I'm going to write that as x squared. I have a 4x and a 4x, so plus 8x plus 16. And then I still have this other guy up here. So now I have a trinomial times a binomial. So I'd like you to try the next step, which is setting up your rectangle like we did up top in example 2. So see if you can multiply this trinomial times this binomial. You might need a calculator because the numbers get a little bit big. So I'll make sure you get a calculator. But I'm just giving you all the different ways that they could appear so that you remember to write them out twice, or how to set up one of these rectangle boxes. What if you get, this would be more of a bonus. So example 3, this would be a good bonus question to remember. I've got to write it out 3 times. I've got to FOIL it to get the first trinomial and then the second binomial. That's a lot of work to get this one correct. You're checking it. I'm just going to write it up here because I can't do the answer in my head. Let's see, 16x, 4x squared, 32x, 64. So let's see, x cubed plus 12x squared plus 48x plus 64. Did we get the same thing? Now, do you see how that's a lot different than if I had just distributed the cube side of the polynomial. So it's not correct to just distribute it over the parentheses. All right, are you ready for a 3 by 3 for your last one on this resource page? So a 3 by 3, right, they're multiplying f times g. That's what this means. Take this and multiply by this. See how there's an x at the end? That doesn't mean you multiply by x again. You're just taking this trinomial times this trinomial. So a 3 by 3 box. So let's see if you can do a 3 by 3. If you can do a 2 by 2, you should be able to do a 3 by 3. It's just a couple extra steps. So it doesn't matter where you put them. So I'm just going to put my 2x squared, 5x, and negative 1 down the side, and 3x squared, x, and negative 5 across the top. You'll get the same answer if you flip-flop where you put your functions. I just want to make sure you get the first box correct. What would be 2 times 3? 6. And what's x squared times x squared? X to the 4th. So let's make sure you got 6x to the 4th in the top left box. I think you can get all the others correct. See if you can get all 9 of those terms correct and see if you can simplify it to standard form at the end. This again would probably also be like a bonus. I probably won't have you multiply a 3 by 3. But if you could do a 2 by 2, you can do a 3 by 3. 1 extra and 2 extra steps. Oh, there could be. That would be 25 multiplication steps. So that's a lot. I don't even think I would do that for fun, but you know. So what the SAT would ask you is they would ask you, what is the leading coefficient of f times g of x? Knowing that the leading coefficient is 6. You don't even have to do the rest of the boxes to get the leading coefficient. Or they might ask you, what's the degree of the function? You don't have to do all the multiplication to know the degree is x to the 4th. So they even wouldn't have you multiply a 3 by 3 on the SAT. They would make it so there's a shortcut. Oh, if I just multiply the first 2 terms, I know it's 6. All right, so I don't know the answer, so I'm going to put my work up here so that I can have an answer for you at the end. This is good perseverance through a long problem. Oops. All right, I think I got the right answer. Maybe when someone gets to the end of the problem, they can check that we got the same thing. Which one? Well, it's negative 13, but then don't I have this positive 5 guy? So there's 3 of them, I think. So I think that that's right, because this would give me 2x squared, negative 10x squared, negative 8x squared. If you notice, they showed up on the diagonals, right? I had like terms here, I had like terms here, and I had like terms here. So if they're in standard form when you're multiplying, they will come out in diagonal like terms. So that was the hardest one. All right, so let's see. Oh, I'm going to leave that up for just a minute in case people are still trying to get to the end. I'd like you to try page 603 for, I don't know, how long is that going to take? Skip ahead to page 603. You may want to start on the back page 7 through 11 first, and then go back to some of those geometric problems because you might need help on perimeter and area. So page 603, if you want to start on 7 through 10 first, 603, start on number 7 through 10 on the back. That way you don't see the geometric shapes and immediately get frustrated. Oops. These are the answers to 603 in case I, for some reason, didn't put this on the video yet. All right.